Hello everyone, welcome to my channel. We have seen what relational model is, and with the help of relational model we could define relational database. So formally we can define relational database as a set of relations R1, R2, R3, Rn, then set of constraints and a set of operations on them. Operations on the relations. So you could think of relational database as collection of relations plus constraints plus operations. So what are these operations? So this is where we come to relational algebra. I'm sorry. Relational algebra. So relational algebra deals with the set of operators which act on the relations and produce different results. So broadly classified, these operations are classified as unary and binary. So there are three unary operators. The first one is select, denoted as sigma. Second one is project, which is denoted by pi symbol. And third one is rename with rho as the symbol. On the other hand, binary operators are union, intersection, difference, then union, intersection, difference, division, join, especially equi-join. Then we have theta join. Then we have Cartesian product. Then again we have left outer join, a right outer join, and full join. Now we need to look at each of these operators with an example to understand what these operators are and how do they help us to write the queries to extract data from the relations. So the first and foremost is your select operator. Select operator will select the tuples based on some condition, and this condition is specified with an expression containing column names and relational and logical operators. Let's say we have a relation employee with the following columns. We have ESSN as the primary key, first name, last name, gender, salary, and department number. So under this we'll have numerous tuples T1, T2 up to Tn. So for instance, employee 100, first name Ajay, K, gender male, salary 3000, department number 2. Likewise T2 as E101, Sujata, P, gender female 4500, department 1, likewise. So you could have numerous tuples here. Now what select does, it will do a horizontal selection. It means the rows will be selected out and output will contain all the columns of the original relation. So employee has 6 columns, so all the 6 columns would be there in the one minute. So when you use select operator, all the 6 columns would appear in the output. So for instance, if I want to select all the employees who draw more than 3000 salary, I would write select from employee where salary greater than 3000. So these operators are called unary because there is only one operand. So always only one relation will be there when you use one of these unary operators, and the result of this is a new relation R1 which contains all the columns of this original table. But if you see now, assuming that only 2 tuples are here in this table, the output will contain only one tuple, namely tuple number 2, because the salary part here is more than 3000. Alright. So select will select the tuples from the relation, and this is a horizontal selector. On the contrary, the project operator, denoted as pi, is a vertical selector. It means you can select out only those columns which you want in the output to appear. So for instance, pi first name, comma last name, comma salary from employee, and this will result into another relation R2. R2 contains only 3 columns from the employee table, but all the rows will be selected here. The output will contain all rows, but only specified columns here: first name, last name, and salary. Alright. So select is a horizontal selector and project is a vertical selector. The third one is rename operator, denoted as row. Now as you can see in the above, that first name, last name, sal, they are cryptic names, they are not full names. So if you want to rename them, you can write first name, comma last name, comma salary. But you need to specify a relation R2 here, because only those columns which are extracted out will be renamed as first name, last name, and salary. Alright. So this doesn't do any horizontal or vertical selection. It will only rename the columns to get a more meaningful output. right? So the three operators are important, and you can use a combination of these in the to write any query. For example, get me first name, last name, and salary of all employees working in department 5, department number equal to 5. So if I have to answer this, I would write select department number equal to 5. Note that column name DNO should be present in the employee table. So this will select only those tuples which match department number equal to 5, and I want only the three columns: first name, comma, last name, comma, salary. Now since I want a descriptive names here, I would rename first name as first name, comma, last name, and third column as salary, as full like that. Put a bracket here and then get the result as this. So the result relation contains a table with three columns with first name, last name, and salary, and only those employee tuples will appear which match this condition. Okay, so you can combine the operators and put them in particular. You could have put a bracket here as well, so that the result of selection is fed to project operator and result of project is fed to rename operator, and final answer is got. Okay, now in the selection expression you can use logical operator and or like that. So what if I have to answer get me all employees who are working in department 5 but they should be drawing salary more than 5,000. So in that case I would have written select department number equal to 5 and salary greater than 5,000. So I'm putting two conditions here to filter out only those tuples which match these two conditions, and I want to project out first name, last name, and salary, and possibly rename them as before. And this should be put in another relation R. Okay, so the expression here contains a logical operator and. Okay, and you could have as well used or operator or not operator. So these are other possible logical operators in the expression. Okay, so you should be able to write relational algebraic expressions. So these are called as algebraic expression, relational algebraic expressions. Okay, so having seen the usage of the unary operators, now it is time to look at the binary operators. So for that we need to take two examples. I'm sorry, I should have chosen this. We need to take two relations. Let us call them as P and Q with column names A, B, and C. Here you can choose U, V, W. Okay, and we'll put some couple of values here. to illustrate the binary operators union, intersection, and difference. Let us say we have data like this: A1, B1, C2, A2, B3, C4, A3, B2, C1, something like that. And then here A1, B2, C5, A3, B2, C1, and A5, B4, C2, something like this. Okay. So we are given two relations P and Q with exactly same number of columns, and the domains have to be same for taking your union operator, that is A union B, or in this case P union Q. So what is the result of taking P union Q? So we know from high school math that union means the tuple should exist in either of the two or in both. If it exists in both, you should include that only once. So the result of this will be, as you can see, if you compare the tuples in both the relations, you have, I think so, I should modify this a little bit. A3, B2, 7, yeah, no, not required. So as you can see, only this tuple is repeating, all others are distinct. So output will contain, you can include one of these columns. So A1, B1, C2, which is not there in Q, then A2, B3, C4, A3, B2, C1, which is already there in Q, so it will appear only once. A1, B2, C5, and A5, B4, C2. So union takes care of including all the tuples. If they're repeating, only once the occurrence has to be recorded. Okay, so this is what is P union Q. So as you can quickly guess what would be P intersection Q. That is, any tuple which exists in both should appear in the output. So again, you could have three columns. As you can see, only one tuple is common between the two. So intersection of this and this will result into A3, B2, C1. Okay, so the result will include only the tuple which is common between the two. That is P intersection Q. Now, on similar lines, you can guess what would be the result of P minus Q. It means the tuple should exist in P but should not exist in Q. Okay. So A1, the result would be, we will have the same three columns. Now as you can see, A1, B1, C2 exists in P but does not exist in Q. So that is fine. Then A2, B3, C4, which exists in P but doesn't exist in Q. But A3, B2, C1 exists in Q, so that will not appear in the output. So P minus Q will be this. Okay, as you can observe, Q minus P will not be same as P minus Q. Okay, in general. So these are the three operators, or four operators when it comes to binary operators. Now, most importantly, we have to see join operation. This is really important. So first thing we shall look at equijoin. So P equijoin Q, you need to indicate which two columns we must equate. Suppose if I say A equal to U, it means the A column values must match the values in Q relation and in the U column. So as you can observe, when you take a join of these two, there is A1, there is no A2, there is A3. So in the result, there will be two tuples. But here in this case, the columns in both the relations will appear in the output. This is one important thing to remember. So A, B, C, then U, V, W. So all 6 columns will be there in the result. If I say this as relation R, then R will contain all the 6 columns. Now what are the entries here? So as you can see, A1 matches with A1 in U column, B1, C2, and here A1, B2, C5. Similarly, if I take A2, A2 is not there, so A3 matches with A3 in, this should be, so first we should record the row in the P relation, that is A3, B2, C1. There is a corresponding tuple here, A3, B2, C1. A3, B2, C1. Not that it should contain the exactly same set of values, even if it is some other value. For example, if it were C4, this would have appeared as C4 here. Only thing, these two values should match. That is, A column value should match U column values. So result of this join operator, which is equi join, equi because there is a equal to operator. Okay, and as you can see here, the values under A and U column are exactly same. Now this becomes a problem because unnecessarily you are including two columns with same set of values. If you want to eliminate that, then you should use a new operator called as natural join, which is a star symbol, and here you can indicate which two columns I should equate, and in the output you will have one less column. So the output will contain A, B, C, V, and W. The U column is eliminated, and of course the result will be same: A1, B1, C2, B2, C5, and here A3, B2, C1, B2, C4. Okay, so this is a natural join, and this is equi. So equi join and natural join are same, just that the duplicate column will be suppressed in natural join. Okay, yeah. Now what is this theta join? So theta join, if the operator between the two relations P and Q, if the operator in the expression is other than equal to, for example, A greater than B, greater than U, in our earlier case, if it is anything other than equal to, like greater than, less than, greater than equal to, less than equal to, not equal to, this is called as theta join. Just the two column values have to be compared. If the condition is true, only then the tuple will appear in the output. So theta join is based on what is the theta operator that is between the two. So in general, P join Q, and there is a expression containing theta operator, which is one of these. So here there will be column C1 and there will be column C2, and this theta will be one of these. Okay. Now moving on further, we have a more difficult operator to understand, that is division operator. Okay, so this is very useful operator to answer some more complex queries. Now for this you need to again consider two relations with two columns. So normally division operator will be between two relations P and Q, where part of P will appear in Q. So normally P contains two columns, A and B, and one of these columns would appear in Q. That is, you will have only B column here. Now let's consider some values here: A1, B1, A2, B2, A1, A1, B2 again, then A3, B1. Okay, and here you have B1 and B2, only two values here. In fact, I should have considered a smaller table here. Now, what is the result of dividing P with Q? So I can specify like this: P divided by Q. Now, to get the result R, again you will create a new relation containing only the first column, that is A column here. This is what is row. Now, this is not the normal division operator that you use in normal algebra. It is slightly different. You need to understand this. So what you have to do is take B1 and B2 and just observe any such pair appears in B column. So you see that this is B1 and this is B2. So there is a pair here. So wherever B1, B1, B2 is there, observe the corresponding A column. If the corresponding A column contains same values, that is A1, A1 like this, or A2, A2, whichever way, the values should be same in the two rows. But here you observe that here it is A1, here it is A2. They are not matching. So you should skip this. Next, if you observe the B1, B2 combination is here. This is B1 and this is B2. For these two B1, B2 pair, there is a corresponding A value which is same. There is A1, A1 here. So if such a output exists, you should put A1 here. Alright. Similarly, if you consider any other B1, B2, there is a B1 here also. This B1, B2 combination, if I take, the corresponding A values don't match. Similarly, B1, B2 here, this B1 and this B1 and this B2, they match, but here it is A3 and A2 here. Okay, so if it were A3 here, you would have included that as one of the output. So the result of dividing P by Q would have been this if the data were like this. Okay, so division operator is a little difficult to understand, but you need to check a pair of tuples. Just check if that pair exists and look at the corresponding A column values. So if they are same, then include that in the output. Okay, so this is useful in answering queries where, for example, find all employees who are working on all the projects on which one Mr. John Smith is working. So whenever you see a keyword all, uh, that is an indication that you must use a division operator. We shall see through an example how this division operator is implemented in a given database scenario. All right. So we saw, unary operator select project, then binary operators union, intersection, difference. We also saw division operator Further, we saw select, project, and rename. Now, what remains to be covered is aggregation of data. Now, normally, when you have a database, we want to find aggregate information. For example, total number of employees department wise, or average salary department wise, or maximum salary department wise. So if whenever you want to group the data and get a summary information, then you use aggregate function. So there are 4 or 5 aggregate function: average, sum, maximum, minimum, and count. So these are the 5 aggregate functions which are available, and you can write aggregate expression using this symbol. Okay, for example, if I want to find department wise average salary, then you would write the grouping attribute should come on the left of the expression or this operator, and on the right hand side you should get average, then the column on which you want to carry out the aggregate operation, and then the name of the relation, and this result that you get. So the result R contains 2 columns: department number and average salary. So for example, department 1, 2, 3, average salary may be 4,000 here, 7,000 here, then maybe 6,500 here. So this is the kind of operation you can perform, and you get the aggregate information like that. All right. So department wise maximum salary, you can find total number of employee. If you want to find department wise, possibly you can write like this. Sorry, you can write department aggregator, then count ESSN, because ESSN is unique. So you have to count the unique ESSN department wise from the relation employee. So what this does, and you can rename them as you can slightly write it away so that you can include department number, comma, total employees. So the result R will contain 2 columns, that is department number and total employees. For example, 1, 2, 3. Here there could be 7 employees, here 5, and 2 employees. So it is useful to write or find aggregate information from the relations, given a relation and the requirement. All right. So we can use alongside your select and join operation, okay, the division operation, and then also do an aggregation on them. So we need to take a concrete example to illustrate the usage of these operators and write the relational algebraic expression. So in our next video, we shall see a concrete example where we can apply all these operators to find answers for the end user queries. So thank you for watching. See you in the next video.